Now, another huge part of data preprocessing is feature engineering. So remember, features are the variables within a data set, or the columns within a data set, right? They describe exactly one variable or one feature of, a particular data set. Depending on the domain, you might have a data set that has more features than it has rows or instances, right? It might have more columns than it has rows. Or you might be in a domain where your data set has far fewer columns, right? And you might want to create more columns. In the second case, or in the first case, you might want to reduce some columns. All of this has to do with feature engineering. So sometimes there might be a feature that you think should be present just because you understand the problem, but it's not there. But there are other features there, other variables there that you can use, combine to create that particular feature you have in mind. That would also be feature engineering. So many times you need to go in and you need to really understand your data and understand what each feature means and represents. And sometimes you might need to remove certain features, or you might need to create new features from existing features. And oftentimes this depends on your domain knowledge. And that's why, machine learning is not as easy as just taking a bunch of data and throwing it into an algorithm, right? You need to understand what that data represents so that you can perform steps such as feature engineering on it. Oftentimes, feature engineering makes or breaks your results. You can give the same data set to two different people, and just because one of them is able to better engineer the features of that data set, they might get a far superior result than the other person, who might even get, a completely useless result. So feature engineering can be used to improve the performance of a model. Okay. Now, common preprocessing steps are, dealing with missing values. If you have missing values in a data set, you have to do something about it, right? And there are different ways to solve that problem, as I'm going to be showing you in the next slide. But dealing with missing values, on its own, and the many different solutions to that problem, that in itself is a very common preprocessing step. Vectorization refers to coming up with ways in which you can represent categorical data, because, at the end of the day, learning algorithms are mathematical algorithms, right, that run on numbers or on matrices. And so if you have a categorical variable, right, such as the color of somebody's hair, for example, that's not a number. So you need a way to represent that numerically so that your algorithm can actually process it and do what it does to give you a result. So you need a way to represent categorical data, and there are different ways to do that, and that's called vectorization. And feature scaling is another very common preprocessing step. So scaling means getting the range of all your variables to be, similar. So for example, if you have data set on, the housing market, you might have one variable which represents the price of a house, and that might range from, like, let's say $100,000 to like $2 million, right? That's a wide range, right? But then you might have the age of the house, which might, range from 0 to, like, let's say 20. So that's a variable that has numbers, has a distribution between 0 and 20. And the other variable is also a numerical variable, which has a distribution between 100,000 and 2 million. Now, these two have very, very different ranges, and this might throw off some machine learning algorithms. So it's always best to scale them both so that they're both, let's say, between 0 and 1, or between -1 and 1. So, this can be done using something called standardization or normalization. It doesn't matter. The point is that at the end of the day, you're left with all your numerical variables ranging between the same two numbers. It could even be between 0 and 1,000, but, mathematically speaking, it's always best to just do it, to have it normalized or scaled to be ranging between like 0 and 1, or -1 and 1. And so that's called feature scaling, and that really cleans up your data set and gets it very nice. And this is also important for optimization as well. It allows your algorithm to just run faster. Again, that has to do with the underlying mathematics within some of these algorithms. And there are other steps as well. I'm not going to go into them. So preprocessing, you can, any number of steps or any type of step that you take to clean up your data before you model it, that's data preprocessing. So these are some of just the most common ones. So some ways of dealing with missing values during data preprocessing. This will completely depend on your data and on the problem you're trying to solve. So your domain, you need to know the domain you're in, right? I work with companies, industries ranging from, medicine, all the way to finance, down to construction, up into energy, right? All of these are different domains and they all have their own problems and their own data. So before you can actually approach a problem, you need to learn a little bit about the domain you're working in. And based on that, and your understanding of the data, you're going to be able to know what the best step for removing or fixing these missing values are. So my job here is just to give you the different options, and it's up to you to get accustomed to picking which one of these would apply in which situation. So one approach would be row deletion. So just removing all rows that have missing values, right? Now this is okay if you have a very large data set and you just have like a few missing rows, right? Let's say you have like hundreds of thousands of rows of data and you just have like 5 rows that have missing data. In that case, you go ahead and delete it because, if you want to be extra safe, you can just look at the distribution of the variables that have missing data and just see if there's any crazy variability or something. But most often it won't skew your data or like screw it up just because you deleted a row or two when you have hundreds of thousands of rows of data. But if you have like 10 rows of data and 5 of them are missing, you can't delete half of your data. So that's what I mean by you knowing your data and knowing your problem and picking which one of these is best. Another way is to backfill or forward fill. And this just means that you fill the missing value with a value that it's immediately preceded by or succeeded by. So you just fill all the values forward to fill the missing values, or you fill up backwards, right? Or you can imputate, which is the safest way. And this is what, you should most often do. Imputation. Imputation means we don't just delete it and we don't just fill it randomly based on what's before or after it. We actually calculate a value for it. So for example, if you have a variable and there's a missing value, let's say you have a data set of humans and one of the rows or one of the columns represents the heights, right? And you have like a missing height. You can, for example, one form of imputation would be using the mean. So you could calculate the mean of all individuals in this data set and use that value to fill in the missing value. So essentially you would be like, okay, we don't know the height of this person, but the average height of this group is this. So if we had to fill it with something, if we had to give it some value, even though we don't know what it is, the safest bet would be to fill it with the average, right? So that's basically what you're saying. Or you could take the median, right? That's another way to do it. You take the median, and what's even better is using k nearest neighbors, which is a clustering algorithm, and it's actually a machine learning algorithm that we're going to cover in the next sections. And it calculates the best value for that variable based on similarities between its other variables and the other rows. So that's a little bit more complex, but I'm going to show you how to do that using the recipes package without really having to know how it's done. So that's pretty cool. Now, vectorization, like I said, refers to encoding categorical data. There are a number of ways. Again, I'm only sharing some of the most common ones. So you can either just replace the categorical variable with integers, right? So if you had like hair colors, which would be like, let's say the options were black, brown, and blonde, and red. So 4 options. So you can just replace each of them with an integer. So like blonde would be 1, black would be 2, brown would be 3, and red would be 4, let's say, okay? So that's one way. Another way is to replace categorical data with dummy variables, also called one-hot encoding, and I'm going to show you how to do this as well. So you essentially, for example, in our hair color example, you would replace this one variable with 4 variables, and each variable would represent hair color. So one variable would be black haired. And if somebody has black hair, it will be marked with 1. And if they don't, with 0. And the same thing with blonde, red, and brown hair. So you're replacing the variable with dummy variables, or you're one-hot encoding that variable. So essentially, the resulting variables would be binary variables. They either contain a 1 or a 0. So you are effectively replacing the data with numerical data, or encoding it. And we have feature scaling. So again, I explained how feature scaling is where you ensure that the numerical variables scale down or scale up to range between like two standard numbers, like 0 and 1. So in the case of 0 and 1, it's called normalization. So when you're scaling a variable to have values between 0 and 1, it's called normalization. When you're transforming data to have a 0 mean and 1 standard deviation, for those of you who are familiar with some statistics or probability, this time, again, we're using the numbers 0 and 1, but now they might not exactly range between 0 and 1, but they have a mean of 0. So you're basically drawing in all the numbers to be centered around 0. So their average is 0, and their standard deviation, so their spread, is 1. So again, if you're not familiar with probability and that kind of stuff, that's okay. But these are two different ways of scaling. So essentially, at the end of the day, what matters is that all your numerical variables have some bounds, and they're not all over the place. One of them is like in the negatives, and then the other one is in the positives, and one of them has large numbers, the other one has very minuscule numbers. You want them all to be scaled and to share a similar scaling. And normalization and standardization are sometimes used interchangeably. For example, in the recipes package, there is no standardization function. The step normalize function is what essentially that it does what we learned here to be standardization, but it's called normalize, right? So it doesn't really matter. Again, at the end of the day, when you're scaling down or up into a certain range and you're standardizing everything, so that's what feature scaling is. I wrote it here: transforming features to be on a similar scale. That is what feature scaling is. And the reasons we do this, like I mentioned before, are for optimization, to make your algorithms more accurate, more, much faster, and just easier to deal with. Now, just some other steps would be like downsampling or upsampling. So your data may be imbalanced, meaning it may have way too many or way too less of one particular case, right? Let's say, for example, red-haired. You might have a data set of 100,000 people, but only like 10 of them might have red hair, right? So the red-haired case would be largely undersampled or like underrepresented, right? So you want to make the number of occurrences of each case equal, just to remove any bias or any skew. So that's when you might want to use downsampling or upsampling. One way to do that would also be you can collapse rare occurring cases into one case called other. So let's say that black and brown are very common, but blondes and redheads are not as common. So you can collapse, instead of having 4 cases, 4 different colors, you can collapse blonde and red into other. Okay, and you can include people with purple hair and green hair or whatever as well in that category. And then you have black and brown. So that's also one approach to solve that problem. That's not sampling, by the way. So sampling is something else. That's where you remove all complete rows or complete occurrences to balance everything out. But you're collapsing into an other is also one approach. And yeah, so those are some of my references for when preparing this presentation. So I'll see you in the next video. Bye-bye.